Welcome back. Now, if I go back to load menu and press play, and let's just say I want to clear out all my slots and make a new slot and load it up, I have a fresh game now. Now, every time I reach a checkpoint, I'm going to save my progress, right? And that's indicated visually by the glow. But if I step off of this, yes, we're deactivating the overlap sphere, so I can't reactivate it. But as soon as I exit and come back, yes, I've saved my progress, but when I press play, it comes back not activated. It's not glowing anymore. And this is because, while we are saving character variables such as attributes and abilities, we're not saving the world state. We're not saving these actors and the states that they're currently in or that they should currently be in. So that's what the rest of this section is about, saving the world state and how we can go about doing that. Now, saving actors is less trivial than you might think. You may think that perhaps you could go into your save game object, load screen save game, and just add an array of actors here, or perhaps even a single actor. Let's just say you tried that. You added a T-array of A actors called saved actors, and you went about saving those and attempting to load them. Well, that's not going to work because an array of pointers is an array of memory addresses. And there's no guarantee that the next time you launch your game that those actors will occupy the same memory addresses. They might, and you might get what looks like working behavior coincidentally. That's if you close your game and relaunch it again right away and haven't given your operating system any chance to run any other tasks that might take up that memory. Sure, you might load back into the same world and you may load the previous state of those actors because you just happen to be referencing that same memory, but that would be a coincidence, and that's undefined behavior overall. We can't actually save actor pointers. It's just not something we can do, just due to the nature of pointers being addresses in memory, and memory shifts around, memory changes, and your actors aren't guaranteed to occupy the same memory location every time you run the game. For that reason, we don't save actor pointers, we save data. So what we have to do is have an array. If we're going to have an array of our saved actors, we need an array of saved actor data. Anything that we wish to save that once we load back up, we can fill in those actors with that data at that point. So much like we have an fsaved ability, we need an fsaved actor or something similar, a struct that determines what data we save for a given actor. So I'm going to make a struct for this. I'm going to say struct f saved actor. I'm going to make this a ustruct with a generated body. And we need to determine what exactly we need to save per actor. Now, this could be any number of things, and it depends on your game. But one of the things that we need is a way to identify these actors. And if the actors that you're saving and loading are persistent, such as our checkpoints, their names should remain constant. So that's one of the ways we can identify them. So we're going to have an f name called actor name. This is what we'll use to identify our saved actor. And I'm going to make sure that this is initialized. So we'll give it an empty f name value. Now, some of your actors that you're saving and loading may have a transform, or in other words, a location, rotation, and scale. And if you'd like to save that transform, you'd put it here. You'd say ftransform, transform. And you can give it an empty ftransform by default and give this a uProperty. These all need to be uProperties, by the way. Now, you could add any number of other variables here, such as gameplay tags like our saved ability has, but there's also a way to serialize an actor and save any number of its member variables, provided that those member variables are marked with a specific uProperty specifier. That specifier is save game. And we'll see how that works. And the way that you can serialize that data on the actor for all variables marked with this specifier is to have a t-array of bytes. Now, we can represent a byte, which is 8 bits of data, as a uint8 because a uint8 is an unsigned 8-bit integer. And a t-array of uint8s is an array of bytes. We can call this bytes, and we can give it a u property. And I'm going to give this a comment that says contains serialized, not really contains, but it is serialized variables from the actor. Only those marked with save game specifier. So that's what bytes is going to contain. Now, we'll learn how to serialize those bytes very shortly. Now, because we created an fsaved actor, it's often useful to be able to add these to an array using addUnique. And we've seen that you can't use addUnique on a struct unless it has an overload for the double equals operator. And we've seen that to do that outside the struct, we have to use inline. So we're going to say inline bool operator double equals. And we say const fsaved actor reference left, that will be on the left-hand side, and const fsaved actor reference right, that's for the right-hand side operand. And we're just going to return left dot actor name. I'd like to compare by actor name, and if it's the same actor name as right dot actor name, I'm considering these two structs equal. So the double equals operator will just compare their actor names and then return true if those names are equivalent. Now that we have an fsaved actor, we may wish to have an array of actors that we'd like to save, but in this game project, we may be traveling to other levels, other maps, which means that an array of actors that are saved for one map make absolutely no sense in another map. So I need a way to distinguish between maps. I need some kind of data structure that can store an array of these saved actors plus additional information such as the name of the map. For that reason, I'm going to make another struct called fsavedMap. Now this will be like fsavedActor in that it's going to be saved to disk, but it's going to represent a map and all the actors we've saved for that map. It's going to be a ustruct, and I'm going to give it the generated body all ustructs need, as well as a couple variables that it will contain. The first of which is going to be a map name. Now, I'm not talking about the user-facing text that we see in the widget. I'm talking about the actual name of the asset. I'm going to identify it by name. I'm going to use an fstring for this and call it map asset name, and give it an empty fstring value by default and a u property. So an fsaved map can be identified by its map asset name, and then it can contain an array of all of its saved actor data, these fsaved actor structs. So I'm going to make a t array that stores fsaved actors called saved actors, and give this a u property as well. So we'll have an array of saved actor data. This is what I'd like to have in my save game object, and because we can have any number of maps that we've been to that we may wish to save actors for, I'm going to have an array of fsaved maps. So down into my load screen save game, all the way down at the bottom, just under saved abilities, I'm going to have a t array of fsaved maps. And I'm going to call this saved maps. So we're going to be saving data per map, and they will exist in this array. Now, if we have an array of fsaved maps, and each fsaved map has an array of its own, this could get quite confusing quite quickly. So for that reason, I'd like to make a couple of useful utility functions, one of which I would like to return a specific saved map based on the name of that map, or the world name. So I'm going to make a function that returns an fsaved map, copy, called getSavedMap with map name. And this can take a const fstring reference, called map name. So this function is going to actually be quite simple, but having it will make things easy for us so we don't have to have a bunch of for loops in our other logic. All I want to do is loop through my saved maps. So I'm going to say for f saved map in saved maps. This could be an f saved map const reference, so as to make this more efficient, avoiding copies. And I'm going to say if map dot map asset name equals map name, the name we're passing into this function. If the names are equivalent, I can simply return this map. But otherwise, I can return an empty saved map, an f saved map temporary. Now, if we're calling this function and we're getting a value, whether we get a valid map or not, well, how are we going to know that this is a valid map or if we're just returning the empty f saved map? Well, it would be nice to have a function that can return a Boolean if we actually have a map with a specific name. So I'm going to make a bool returning function called hasMap, and this will take also a const f string reference called mapName. So we can check to see if our save data has a map with this specific map name yet. That's useful to know because if we're trying to save data, we need to know if there's an array of actors in the saved data or not. So this is going to be similar to the function above. It's just going to loop over our saved maps. It's going to check the names against the name passed in. And if we get a match, we're going to return true. And if we don't get a match, we're going to return false. So with that, we have a couple of utility functions that will be useful for us. So now that we have some data structures designed to save some data, we have our saved actor and a saved map which has an array of saved actors, and we have an array of saved maps. How are we going to save the world state? How are we going to save the data in our world? That's the next step. So we're going to need some functions to save that data, and we'll do that next. I'll see you soon. Check. Now, before wrapping up, we do need to realize that map name is already a member variable on our save object. So we do need to make sure these input parameters are not using that same name. I'm going to change them to in map name like so, and make sure that we're using I'm going to change them to in map name in both cases here for both of these, and make sure that we're changing these to in map name in the functions. Be careful to replace both usages so as not to use the member variable map name. So with that, we should now have code that can compile. So in the next video, we're going to learn how we can serialize this data by saving the So in the next video, we're going to create some functions that we can use to actually save this data to disk when saving the world state. I'll see you soon.